Yeah, fine. Best regards from Munich, and I would love to be with you in person, but we have to do it this way. So more than happy to contribute to today's discussion and to illustrate some of the things that have been discussed over the day or will be discussed.
Well, it's very good to have you with us, Dr. Becker. So, Thomas, let's kick off, because your title is a fascinating one, and I think you're going to give us a few definitions of some of these key terms. We've been talking about decarbonisation and electrification. That's kind of the theme of today. But beyond that is this sort of growing realisation of the importance of sustainability and circularity. Tell us about those terms.
Absolutely. I mean, if you look at what Paris requires, if you want to be able to not claim or have an ambition to, but to demonstrate and prove that you are on track to delivering on your contribution to the Paris Agreement, it is about bringing down the entire footprint of your product. And in the case of BMW, if you take 2019 as a base year, we had a footprint per car of 55 tons of CO2. So that includes the usage on the road, the CO2 emitted by burning fuel over 200,000 kilometers of a vehicle's lifetime. That includes the CO2 of our own production, and it includes the CO2 that comes out of making our parts, the steel, the aluminum, etc. And if you like, in the old days, 80% of that overall CO2 balance sheet was on the road. It was coming from the exhaust pipe. And if you want to claim, I'm Paris compliant, in our case, it means to bring down those 55 tons to 40% less in 2030. And this is a time horizon which is not 2050, not 2040, but it is about the things we decide today and where we have an impact today. So what does that mean? First of all, it means to bring down the on-the-road emissions. That's obvious, and this is what electrification is about. But it also means you have to address your supply chain and you have to do your own job in your own facilities. But in order to bring down, to start with that, the footprint on the road, it's about ramping up electric cars, and at the moment we are seeing significant progress here. I mean, BMW doubled its sales of electric vehicles last year compared to 2020. Under difficult circumstances, but also with a lot of policy impulses that came during COVID. The Mini brand certainly is a spearhead of electrification. We have also been doubling not only the numbers of our electric Minis made in Oxford, it is also now the best-selling Mini product with a 10% share of the sales last year. So things are looking positive in terms of ramp-up. But the crucial factor is not how to get the first 20 or 30 or even 40% of your customers into an electric car. It is about the last 20 or 30%. And here is where the crucial importance of infrastructure comes into play. And here's some data on the first slide that I brought with me, which illustrate the situation in Europe. And as one can see here, I don't know, is it visible?
It is, yep.
Okay, cool. As you see here, there is a group of top 6 countries which have a very high rate already of public charging, and this is the indicator I would use here, per 1,000 cars. The Netherlands and Norway are leading by far. But clearly, these are not the biggest markets in Europe. Neither are Sweden, Luxembourg, Belgium, Switzerland, Austria. They are also not bad. So this is the lead group, if you like. And then you have the big, relatively advanced markets of the UK, France, Germany, which are, so to speak, in the middle. And then you have another piece, which is the more problematic one. Big markets, Italy, Spain, Poland, which are lagging big deal. And as you can see in the numbers for some big European cities, these are not villages, these are Naples and the Forth. It's in the 2-digit range. In the meantime, we have hundreds of chargers in Munich, for example, thousands in the region of Amsterdam or Rotterdam. But this is unsustainable if you look at the European Union if we do not speed up in the entire market of Europe. And this is why we put such a strong emphasis as BMW on the need to synchronize the supply side policy, which makes us launch more and more electric vehicles, with the demand side policies, which impact customer choice. And to be a little bit blunt, no mayor in China has a choice whether or not to support electric charging. In Germany and in many other places, it is not even the mayor's decision, it is borough council decisions which matter where to put a charger. So we need to make sure that also in Europe, it is a very clearly understood obligation of national, regional, and city governments to do their job. We do ours together with many other players in the industry in ramping up the fast charging network named Ionity along the motorways. This is where we can negotiate with a limited number of operators and rapidly advance the rollout of that part of the infrastructure equation. But we cannot convince the borough council of, let's say, a part of Thessaloniki to do that. Here, leadership is required from government level. So if we look at this picture here and go to the other one, which is about the EV share in those markets, it is identical with one exception. So what you see on the second slide is the same countries leading, but the UK, which according to the other logic would have been ahead of Germany and at the level of France, is actually further to the right than where it would belong at first sight. You see the same difficult situation in Italy, Spain, Poland, to name these examples. So what this shows is that not necessarily is the national average alone an indicator of where a country is. And the explanation comes from the very detailed, excellent data from SMMT, which you see on the third slide, which explains why the situation in Britain may be different from, for example, Germany. And this is the massive concentration of infrastructure in London. So as SMMT has indicated, there are 9 cars per public charger in London and 55 cars in the Northwest.
Let's just let me stop you there, Thomas, for 1 second. Let's get the third slide up so that we can see what you're discussing. There we are. Wonderful. Thank you.
So, and I've been to Glasgow for the climate conference and also directly looking at things, there is a big difference to London. And also, if you look at our market, if you take the massive growth of the electric Mini demand, I mean, these are the typical Mini customers. And this is why Mini will clearly fully electrify until 2030. These are people who commute into town, who will have a charger at their home, who don't travel big distances, who may have another car. But the situation is completely different for a professional user of, let's say, a 5 Series touring BMW, who is facing still way bigger challenges in very many markets, not only within the UK, but in many other places. And this is why things are not as simple and easy as they may seem. We require a much closer collaboration on the infrastructure side and more political leadership, as also has been said by Mike this morning and also by Andy. So let's assume that we ramp up electrification as we foresee it today, which means every second BMW in the world is fully electric by 2030. And that means that it will be more than 50% in markets like the United Kingdom. What does that mean for our overall Paris equation? It means that the share of the footprint that we leave on the road will be less than a third of the overall footprint. It will shrink massively. And as another illustration, if we wouldn't do anything about our footprint in the supply chain, the CO2 that is embedded in our parts would be more CO2 per vehicle on average than what we emit at the tailpipe before 2030. And there is a reason for that, which you see on the chart number 5, which is relatively simple. If you don't do anything about it, an electric car has twice as much CO2 embedded in its making than an ICE car. And this is due to the footprint of the battery and the electric drivetrain. So that means that with 50% electric vehicles in 2030, our footprint in the supply chain would go up from 12 tons to 80 tons. But in order to be Paris compliant, we need to end up with half of that. So we need to cut the CO2 footprint of our supply chain massively in order to be compliant with Paris as a company and in order to bring the maximum benefit of electric cars, so that not part of the impact we have on the road is offset by the impact in the making of the vehicle. And this is why the supply chain is an essential part of our CO2 abatement strategy, which I would like to briefly explain, which is also on slide number 4. If you take a car that we make today, like the i4, for example, you have about, and this is on the chart number 4, if you could take that one, please. You have a big piece, like 1/3 more or less, which comes from the battery cell. Then you have steel, you have aluminum, you have copper and plastic. All of those highly energy intense products. And there are 2 ways to bring down the footprint of these materials. One is to replace gray energy by green energy. And we have, for example, negotiated with all our battery suppliers, and they are contractually obliged to do that, to exclusively use green electricity when supplying BMW. So that reduces the 4.9 tons of the battery cells. We do the same at the moment with very many of our big suppliers of aluminum and steel. In aluminum, it's about electricity. I mean, it's about electricity that can be generated by water, by wind, or by coal. So here we are making rapid progress in getting CO2 down of that part of the equation. For steel, it is much more demanding because the established steel mills operate with coal as a basic resource. So the question is, how can you, for example, use electric arc furnaces using higher scrap rates to bring the CO2 footprint down? Will we in the future see hydrogen replacing coal in steel making? So it is here about ramping up the decarbonization over long-term discussions with suppliers in order to have a reliable pathway towards the Paris objectives. Chemical industry, highly energy intense, and for example, a high usage of fossil natural gas at the moment. When will there be the time where this can be replaced by renewable alternatives? It's again also about electricity generating hydrogen, hydrogen then fueling industrial processes. Very clearly, this is one approach, addressing the energy footprint. But the other big lever is recycling. If you take aluminum, 3/4 of the CO2 footprint can be saved if you use recycled aluminum in combination with renewable energies. So the same applies for steel, and it also applies for battery materials. But as you can see from the gray indications here on the chart, the green, sorry, we are already pretty far in metals. But for batteries, it's much more challenging, simply because there is not so much battery volume coming back this year or in the next 10 years. So as we will have to ramp up recycling rates of batteries, we need to expand the recycling rate of steel and aluminum. The faster, the better. The issue here is quality and availability. It's about how much automotive-grade aluminum do I get out of recycling processes. And unfortunately, even 1.5% of copper contamination in aluminum makes it unusable for any surface that comes into contact with water. It means it's not corrosion resistant anymore. So that means that better recycling technology, also designing for recycling, is crucial. As an industry, we have 20 years of lightweighting using more and more complex composite materials, which tie materials together in a way that it is very hard to separate them later. We are really radically questioning that approach. We have also internally decided that the burden of proof has to be turned around. So far, it was easy for somebody who was designing a car and defining the requirements for the material to say, okay, I take virgin material. If somebody needs recycled stuff, the burden of proof is on this guy. Now we said secondary first. By default, you have to go for secondary material and you need to justify needing primary. We also seek to have less complex electronic architectures in order to reduce the risk of copper, small pieces of wires ending up in each and every piece of the car, just to name one example. So a lot is happening here, fortunately. A lot of companies, a lot of innovative startups, as much as established companies, are now putting a lot of brainpower in these parts of their product footprint. And we work with many of them, be it those who are working on hydrogen-based steel, be it with the plastics industry. But clearly, in order to be credible in so doing, we need to do our homework ourselves. We need to demonstrate that what we preach to the others is what we do ourselves. And chart 6 gives a few examples from our British operation. The solar roof we have in our mini plant in Oxford is one of the biggest in the United Kingdom.
Let's see chart 6.
Let me be very clear, this is the oldest car plant in the world that is still running. All the ones who have been there before have been shut down in the meantime. And so this means that you can produce sustainably, not only if you build greenfields. You can also upgrade existing facilities to a high level of sustainability. We use renewable energy like biogas for our logistics. And it's a very, let's say, seemingly easy example. Mini now launches the first fully circular wheel. So an aluminum wheel that is only made of recycled material. You would wonder, hey, I mean, there are millions of aluminum wheels out there. Why can't you organize a proper cycle of aluminum? It is not there so far. So circular economy means to rethink the logistics, the processes, the question, how do I get material back from the market? How do I feed it into a new material? So very clearly, we aren't there yet. We are on a journey. We accept and appreciate being held accountable also by our customers. And many of our British customers are corporate customers who are very competent in the field of sustainability and want us to tell them, listen, what are you doing about your footprint? And we want to deliver on that. And finally, if you look at the chart number 7, this is what we have been showing in Glasgow, as well as at the Munich Motor Show, the iVision Circular, which is not a car that will go into serious production, but it is a vision vehicle that is about showing that technically, you can make a car without primary resources. So you can make a car that is fully made of recycled stuff, be it the textiles, be it the metal of the surface, be it the wheels. The issue is not technical feasibility. It's about market development, available volume, technical quality, and price. And this shows that we cannot just pull a switch and go from today's technology to tomorrow's fully circular vehicle. We need a lot of partnership. We need partners in the supply chain. We need partners in government to set the right rules and criteria for what we are doing. We need a joint understanding of data and transparency. But we also need the right way of rethinking the equation. And so what we have shown here is a thought-provoking device. And as one could see in the very many intense discussion we had, for example, in Glasgow, it has worked as such. So in closing, I think we have lots of opportunity, but there is a bigger job to be done than just going from one different technology to the other. We need to be careful and we need to be much more collaborative than we have been in the past.
Very inspiring to hear you talk, Dr. Becker, and I think that's source for much optimism, actually, in what you're describing going on within the industry and also in your relationships with government and the enthusiastic efforts to try and improve the infrastructure. I think we've got literally 2 minutes left on your time slot, and I've got lots of questions myself, but much more important we hear from the audience here. Time for one or perhaps two questions, if anybody has one for Dr. Thomas Becker. If you want to put your hand up and wait for a microphone, that would be great. Yes, the gentleman in the middle here, just as a microphone approaching, if you can say who you are, that would be wonderful.
Thank you very much. Keith Budden from Senex, fascinating presentation. Do you think the time is right to move away from a value-added tax to a resource-added tax to make sure that the companies that do innovate have a beneficial place within the market? Thank you.
Well, that's a bigger thing, I think, that I'm capable of answering. What we have supported as BMW always was linking direct vehicle taxation to the CO2 footprint. So meaning twice as much CO2 means twice as much tax. There is a risk of, let's say, industrial policy related distortion of that, but in principle it's right that taxes reflect the environmental impact. The equation of value-added taxes seems to be a lot more complex than that, but I think taxation overall can and has to play a crucial role in bringing this about. For example, when it is about the ratio between the taxation of various forms of energy. And governments can play a crucial role in stabilizing expectations. Because, as I tried to indicate, we can only spend the euro once. And whether to spend it for recycled aluminum or green energy in the battery is always a choice. If you means you have to permanently compare where do you get the biggest impact per euro spent. And the government has a strong influence on that via taxes, via CO2 pricing, via emission trading systems. And revisiting this entire system with the question, does it contribute to move things ahead or may it do the contrary, is hugely important.
Thank you for that, Thomas. And I think that we have to draw that to a close, ladies and gentlemen, which is a shame because I know that so many interesting issues were raised in that discussion. But please join me in thanking Dr. Thomas Becker from BMW.
Thank you so much.